Have you ever stared at the night sky and felt impossibly small? Every star you see is a sun, some are bigger than ours, with light that will keep traveling long after you and I are gone. Some are smaller, cooler, with planets that may have been bathed in oceans for billions of years. And here's the thought that has haunted scientists and dreamers like myself. If there are billions of stars in our galaxy alone, and trillions of galaxies beyond, how could we possibly be alone? Yet, despite all the odds, all the statistics, all the hope, the universe stays silent. No messages, no undeniable signs, nothing that says we are here. Today, we dig deep into the question, are we alone in the universe? Let's start with the math. Astronomers estimate our Milky Way alone contains 100 to 400 billion stars. The Kepler Space Telescope has shown that planets are more common than stars, meaning there are likely hundreds of billions of planets in this galaxy alone. And here's where it gets staggering. Roughly 1 in 5 Sun-like stars could have an Earth-sized planet in the habitable zone, where temperatures allow for liquid water. If true, that's up to 40 billion Earth-like worlds in the Milky Way. Now, zoom out. The observable universe contains an estimated 2 trillion galaxies. If even a fraction of them are like ours, the number of habitable planets could be in the septillions, a number so large you can't truly picture it. Statistically, the odds of us being alone seem almost impossible. And yet, here we are, still searching. The Fermi Paradox asks the most haunting question in astronomy. If life is so likely, where is everybody? In 1950, physicist Enrico Fermi casually posed this over lunch. And the question has haunted science ever since. Possible answers? The great filter. Maybe intelligent life is rare because something wipes civilizations out before they can colonize the stars. The zoo hypothesis. Maybe advanced species know we are here, but they are deliberately avoiding contact, watching us like animals in reserve. The dark forest theory. Popularized by Liu Cixin's novels, it suggests that the universe is dangerous. Civilizations stay quiet because announcing your presence could invite destruction. This paradox leaves us with two equally chilling possibilities. We are either alone or we are not, and for some reason we are being ignored. Now, even though the universe stays silent, we have been listening. Since the 1960s, SETI, the Search for Extraterrestrial Intelligence, has been scanning the sky for radio signals not made by nature. So far, nothing definitive, but there have been anomalies. In 1977, the 72-second radio signal, later nicknamed the WOW signal, was detected from the constellation Sagittarius. It was so strong, so unusual, the astronomer Jerry Eman circled it on the printout and wrote one word only: wow. It has never been explained, never repeated, just a brief whisper, and then silence. And before 1992, we had no confirmed planets beyond our Sun. Today, thanks to missions like Kepler and TESS, we have thousands. The discovery methods are beautifully indirect. A star dims by a fraction when a planet crosses its face. A star wobbles as an unseen companion's gravity pulls on it. From those faint signatures, we calculate size, orbit, temperature, sometimes even hints of the atmosphere. And there are a few that stand out. One of them, Proxima Centauri b, just 4.24 light years away, in our nearest star system. It orbits a small, active red dwarf. Its star flares. That could be hostile, but it sits in the habitable zone. If it has a magnetic field and an atmosphere, there could be oceans sheltering in the red light. The TRAPPIST-1 system. 7 Earth-sized planets orbiting a faint star, with 3 in the habitable zone. Imagine a sky where neighboring worlds loom large, close enough to paint shadows on your ocean. Kepler 452b, sometimes called Earth's cousin. Slightly bigger than Earth, in a star's temperate zone. Older than our planet by more than 1 billion years. If life began early there, it would have more time to become whatever comes after intelligence. And now, with the James Webb Space Telescope, we can do more than find these worlds. We can sniff their air. When a planet passes in front of its star, a thin film of starlight filters through its atmosphere, if it has one. Different molecules absorb different colors. Oxygen, methane, water vapor, carbon dioxide. If we one day see oxygen and methane together in steady amounts, that will be a powerful hint. On Earth, those gases don't coexist for long without life renewing them. This is called biosignature science. It is slow, it is careful, but it's our first real chance to read the weather report from a world we cannot visit. And yet, sometimes the universe doesn't send us a world to study. Sometimes it throws one past our door. In 2017, astronomers in Hawaii spotted something unusual, an object on a path that proved it wasn't from here. It wasn't orbiting our sun. It was simply passing through. They named it ʻOumuamua, a messenger from afar, arriving first. It was small, probably a few hundred meters long. It reflected sunlight strangely. Early models pictured it as a cigar. Later work suggested it might have been more like a flat shard. Most confusing of all, it showed a tiny, non-gravitational acceleration, as if something, besides the sun's pull, was nudging it. Comets can do this, as ices sublimate and vent gas. But no comet-like tail was seen. What was it? There are natural explanations. An exotic ice that evaporated invisibly, a fragment from a shredded airless world. One scientist proposed a thin shard of nitrogen ice, the kind you might find on the surface of a Pluto-like planet. Another argued we should at least consider an artificial origin, a discarded light sail. a broken probe. The claim is unproven and controversial. The safest statement is the simplest. ʻOumuamua was real, interstellar, and odd. It reminded us that the space between stars is not empty, it has traffic. If a strange visitor can pass unannounced, if signals can whisper once and then never again, what does that say about the kinds of life we should be prepared to find? When people say alien, they often mean human, but different. 2 eyes, a mouth, and a similar sense of the world. Biology doesn't owe us that. Life, even here, is far stranger and more flexible than our imaginations used to allow. Consider extremophiles. These are organisms that thrive where life shouldn't. In scalding hot springs rich in acid. In deep sea vents where water superheats under crushing pressure and chemicals replace sunlight. In salt flats, so concentrated they crystallize into razor fields. In Antarctic lakes, sealed under ice for hundreds of thousands of years. In nuclear reactor water, inside rocks, in clouds. These are not edge cases, they are success stories. Life adapts. It finds metal to breathe where oxygen is scarce. It swaps sunlight for chemistry. It rewrites the rules we made for it. If life can bloom in darkness under ice, if chemistry can invent metabolism without sunlight, then the universe may teem with life that never built radios. Life we will never hear. Life we might only find when we learn to go. Silence is not proof of emptiness. It's proof of our current limits. Limit 1. Distance and time. The nearest promising worlds are light years away. If a civilization 1,000 light years distant sent a signal to you the year your great-great-grandparents were born, we'd only be hearing it now, and our reply would take 1,000 years to return. Most channels we are listening to haven't been open very long. Limit 2. Selection bias. We search for life that looks like life here, because it's the only sample we have. Carbon-based chemistry in water, temperate surfaces, air, but the space of possible life is larger than our imagination. Methane seas, cloud layers, subsurf oceans, lit by rock and heat, not sky and sun. Limit 3. Brief windows. Civilizations might become, but short-lived, flickering on and off across galactic time. If their windows don't overlap ours, the sky feels empty, even if it isn't. There's comfort in another answer too. Maybe we are, just early. Maybe the universe has only recently produced enough heavy elements, calm stars, and stable orbits for complex life to become likely. Give it another billion years, the sky might hum. And if we are early, our responsibility is heavier than we thought. If we are late, our humility should be deeper than we feel. And if we are alone, then life is rarer than gold, and we are something the universe does not often make. Right now, Earth is a blue whisper adrift in a black sea. We send signals, we listen, we guess, we wait. Maybe the universe is empty. Maybe it's full, but quiet. Maybe the signal we needed arrived once, long before we learned to hear, and will arrive again long after we are gone. Either way, the night sky is a question that refuses to close. We are not here to prove and not here to disprove. We are here to search, carefully, patiently, joyfully, for those who wonder. Thanks for watching.